section 5.3 is about special factoring. So, these are not rules, except for the cubic rule, which I'll highlight, that you need to memorize because we can solve these the old way by finding the factors of AC that add up to B. So let's take a look at the difference of two squares. If A and B are real numbers, then A squared minus B squared equals A plus B times A minus B. I'm sure you noticed that in our section covering FOIL when I had you take x minus 3 times x plus 3. I'm sure there were quite a few examples on the homework. And you would see that our middle terms would cancel, and we were left with a difference of two squares, x squared and 9, which is 3 squared. The difference of two squares, two terms factors, is the product of a sum and a difference of those terms. So here I've got x squared minus 36. 36 is 6 squared. So I could, if I memorize this shortcut, label my a's and my b's. In this case, a is x, b is 6. So this becomes x plus 6 times x minus 6. Or it could have been s minus 6 times x plus 6. But what if you didn't remember this rule? You can still find the factors of AC that add up to B by adding a placeholder, like we did when we were doing polynomial long division. So now A is 1, B is 0, C is negative 36, AC is negative 36. What are some factors of negative 36 that add up to 0? That's just going to be 6 times negative 6, and then you could go ahead and factor by grouping. Oh yeah, I put that down here, just so you know. If I have 4a squared minus 64, the first thing I want to do is pull out the greatest common factor. So I have 4a squared minus 16. In this case, my capital A is A. My capital B is 4. So I'm left 4 times A plus 4 times A minus 4 as my final answer. You always want to make sure, if you can, to pull out the greatest common factor first. So let's go through two more examples looking at the difference of two squares, and we're going to use this method of finding out A's and B's. So here I have 16x squared minus 49y squared, and I need to identify my A's and B's. So I'm going to want to take 16 squared, which is 4, and then x squared, which is x, and then for B, I've got 49, and the square root of that is 7, and y squared, which is y. So this is going to factor to 4x minus 7y times 4x plus 7y using this form. For problem 2, I've got x to the 4th minus 81. Well, x to the 4th, I could rewrite that as x squared squared. So that means my a is x squared, and my b, 81, that's 9 squared, so my b is 9. So I can rewrite this as x squared minus 9 times x squared plus 9. But look at this. This right here is also a difference of squares. In this case, my new a is x and my new b is 3. So this is going to factor into x plus 3, x minus 3 times x squared plus 9, which is prime. I can't factor that any further. Another type of special trinomial is perfect square trinomials. I would recommend factoring this the old way. Don't memorize this weird shortcut where we find the factors of AC that add up to B. So in this case, we can see that if we had a plus b squared and we FOILed that out, we would get 2 times a times b as our middle term, because a times b would occur twice. Let me show you why. So if I've got a plus b times a plus b That becomes a squared plus ab plus ab plus b squared. So there's 2 of that middle term. But what I would do is I would go ahead and find the factors of AC that add up to B. So in this case, AC is 9, B is 6. What are some factors of 9 that add up to 6? 3. I've got x plus 3 times x plus 3, because 6 is 3 plus 3. Nice little shortcut. Let's work through these examples. So remember, I had a minus b squared would be a squared minus 2ab plus b squared. I'm going to use the shortcut for these, but I don't like it. Just so you know, I don't like it. So in this case, my first term is a perfect square. It's my a in this case would be 12 x. My b in this case would be 5. And let's just verify that that middle term is indeed negative 2ab. So if I took negative 2 times 12x times 5, let's not use an x because that might get confusing. I get negative 24 times 5, that's negative 120x. Okay, cool. So this is going to factor perfectly into 12x minus 5 squared. For this next term, I've got 4x squared and 49y. My a is 2x, because 2x squared is 4x squared. My b is 7y, and I just got to verify that my middle term is 2 times a times b. That gives me 28 xy. Oh no, that doesn't work. So we cannot factor. It is not actually a perfect square. Trinomial. So these are the only 2 rules you'll need to memorize. They're for factoring the sum and difference of 2 cubes, and I want to prove to you at least why factoring the sum of 2 cubes into this form works. So I'm going to go ahead and FOIL out a plus b times a squared minus ab plus b squared. So you can see how this magically becomes this. Well, not magically. Mathemagic, I guess. Okay. I'm going to go ahead and distribute like we know how. A times a is a cubed. A times a negative ab is negative a squared b. A times b squared is a positive ab squared. Remember, we write our variables alphabetically. Then I have a positive a squared b minus ab squared plus b cubed. Notice how these middle terms all cancel out. I've got a negative a squared b and a positive a squared b, and an ab squared and a negative ab squared. So that's how those all cancel out. So I would left with a cubed plus b cubed. Hooray! Plus b squared. So we always want to factor completely. We're going to first plot the GCF if we can, and then we identify our a's and b's. So here I've got the product of the sum of 2 cubes. A is x, b is 27. It's important to note the first few cubes are 1, 8, 27, 1 is 4 is 16 is 4 is 64. So those are the first 125. Those are the first few cubes. So I could rewrite this just by filling in my a's and b's. I got to rewrite this as a plus b, which is x plus 3, times x squared minus 3x plus b squared, which is 3 squared, which is 9. Number 2, my a is going to be 3x, my b is going to be 5, and I've got to use this, again, the sum of 2 cubes rule. So I've got 3x plus 5 times a squared, which is going to be 9x squared, minus a times b, 3x times 5 is 15x, plus b squared is going to be 25. For this last example, we can see that neither of these is the difference or the perfect cube yet. So let's factor out their greatest common factor, which is a 3. I've got 3 times x cubed minus 8. So now my a is x and my b is 2. So this is going to factor to 3 because we can't forget that greatest common factor we factored out. X minus 2 times x squared minus 2x plus 4. Again, we're just plugging in our a's and b's.